So welcome to the runtime error. Today I'm really happy to share you that we are going to start with a new playlist that is on linked list. We will discuss every single details of linked list, and one of the most important part, that is we will also discuss a theory interview questions as well as the coding interview questions of linked list. So I request you to follow this playlist right from the first part till the end part so that you can master the linked list. So without getting any delay, let's start with the linked list. So before we start with the linked list, let's check what is linked list. So first part I will say what is linked list. Now we know that linked list is a linear data structure as I have shown you in the diagram. It is a linear data structure, but only the point is it may not contain the element present at a contiguous memory allocations. What do I mean is, say for example I have element called as 7, so 7 is present at here. Now I contains element called as 3, now 3 might be present over here, and say for example I contains one more element called 2 and it might be present over here. Now the point is, how am I calling it as a linear data structure if those elements are not stored in a contiguous allocation? In linked list, what we do is we got a special pointer which is pointing to its next element. Now say for example the next element after the 7 is 3, so I will simply point it to 3, and the next element after the 3 is 2, so I will simply point it to 2. Now the question comes, what is pointer, how do we point it, how to represent the element in the linked list? We will see these things, every single thing in detail. Right now we will be having some introductory part. So I hope so you understand what do you mean by linked list. So simply I will say that linked list is linear data structure but not present in contiguous allocation. It is not present in contiguous allocation. As I shown you that 7 might be present at address say for example 100, 3 is present at an address say for example 700, and 2 might be present at an address called as 400. So what basically we did is we're also storing the address of a next element along with the element. So for this type of storing the element, we need some different kind of data type so that we can store both the value as well as the address of that value as well. Now as we saw here, what is linked list? Now check why do we need a linked list. For example, if we have the data structures like array, now the question comes, why linked list? Now there are lot more advantages and disadvantages when you come across any kind of data structures, and this is the reason why we are dealing with not only one data structure but more than one data structure. Now if you talk about the array, what does array has is, array has a fixed size. It has fixed size, but if I talk about the linked list, it does not have the fixed size, which means it is dynamic and this is static. Now the question comes, hey, if I have the array of fixed size, then why do I need a linked list of not fixed size? Say for example, if I know I want to store only 5 elements, then why should I use array of a 5 size rather than using a linked list? But you can use the array to store the element of size 5, but the point is, say for example if I have the array of size 100, but unfortunately we got only 50 elements. The point is the remaining 50 element space is wasted, isn't it? Because I'm saying that the 100 elements are present, but unfortunately we are having just 50 elements. So remaining these 50 elements will be wasted. The space of 50 elements will be simply wasted. Now the question comes, okay, I will declare the array of size 50. Now say for example by chance I have 100 elements. Now I need to store. I have stored 50 elements. Now do I have the space to store the remaining 50 elements? Absolutely no. So this is the biggest disadvantage of using the array. But if you come across a linked list, say for example, if I have 1, if I have the 2, now I want to store, say for example, a 7. Okay, I easily store as 7. Now say for example, I have 50 different elements that I need to store. I can simply create it at any time. I don't need to fix any kind of space for the linked list, and this is the beauty of using the linked list. That is, it's help us to store the elements dynamically, which means we can store the elements during runtime. But when you go to the array, this is present at during compile time, and this is mainly present at runtime. So this is the best beauty of using the linked list. Now the second advantage of using the linked list is insertion and deletion becomes lot more easier as compared to array. Say for example, if my array has 1, 2, 3, 4 and 5. How many elements I have? 1, 2, 3, 4, 5. Now size of array is 5. Now say for example, I want to insert element called as 7. Put this element in array. So before I insert any element in the array, what I need to check is there any space available to store the number 7? Now I don't have any space. Now say for example, I have the space to store, and now I want to insert this 7 in between here, so that my final answer could be 1, 2, 7, 3, 4 and 5. Now before inserting the element inside the array, we know that we need to check whether the space is available in the array or not. Okay, I got space, but the point is, what I need to do is I need to move all the elements from the 3 to its right side. For example, 5 need to go over here, 4 need to go here, and 3 needs to go here, and then only I can insert here as 7. Can I say just to insert a single element, I need to perform these many of operation? That is, first check if space is available or not. Second, move all the elements. Move all elements. So these are the things we need to perform just to insert a single element in array. But now say for example, if I have the linked list, I have say for example, I have 4 nodes. Now I want to insert an element in between here. Now do I need to shift, or do I need to check whether the space is available in linked list or not? No. Simply what can I do is I can simply store the address of this node into this node, and the address of this node in this node, so that this will be pointing to this and this will be pointing to this. So I simply inserted element. So how cool is this using linked list, so that we can easily insert and delete any element. So this is the reason why we need a linked list. I hope so you understand the overall concept of linked list. I will try to revise it once again. Linked list is dynamic data structure, right? That is at runtime. Most importantly, it is not present at contiguous allocation. So in order to make it linear, we use a concept of pointer to store address of next element. To store the address of next element. And second thing we saw is why linked list. We saw a disadvantage of using the array, that we know that the array is of fixed size, whereas the linked list is of dynamic size. It is a static, it is a dynamic, that is, we declare the size of array during the compilation process. But here we don't need to declare the size of linked list. We can create and delete the node at any time. And the second disadvantage, we saw that insertion and deletion in array becomes lot more difficult, but when it comes to the linked list, it becomes lot more easier. Now the biggest question is, how do we represent an element in the linked list? Now we come across a term called representation of linked list. So the first point is element is mainly shown as node. Now what is my node? Now I will draw a single node. So this will be the single node for me, and this node contains the two things. First one is data, and the second one is address of next node. I hope so you got this. Now let's check. Say for example, if I have my first node and the address of this first node is 100, I have my second node whose address is my, say for example, 400, and I have my third node whose address is, say for example, 600. Now I am storing the element called as 7, 3 and 4. Now 7 will contain the address as 400, so that it will be pointing to this node. 3 will be holding the address of next node, that is 600, so it will be pointing to this node. Now the question comes, do I have any node present over here? No. So how we will come to know that this is the end of the linked list? This is the end of the linked list. How we will come to know that? Because I don't have any node present over here so that I can point to it. So for this, what we do is we basically represent it as null. Now null indicates that end of my linked list. I hope so you got this. Every single node contains a two part. One part contains the data, then second part contains the address of a next node. Here I have shown this, the address of next node, that is this one. Address of next node, that is this one. So hope so you understand how do we represent the element in the linked list. Now let's check how to declare this. Now I will be using a struct data structure, that is called as a structure, and I will be calling it as node. Now what are the two parts present in my node? What are the two parts that are present in my node? As I told you, one part is data and the second part is address. Okay, I have declared what is integer data. Okay, now I need to store the address. For this I will say called as next. I will call it as a next. Now the question comes is, in order to store address, what kind of data type we need? What kind of data type we need? Now if I ask you the question, whose address is this? Can I say it is of next node? Whose address is this? Can I say it is of next node? Which means I am going to hold the address of next node itself. And if I ask you what is the data type of that node, then the data type of that node is node itself. So can I say I need to store the address of struct node itself. Of struct node itself. So this is my representation of my node. How does it will look like? So this will be my node. This will be my node which contains two parts. This called as a data and this called as a next. This contains address and this contains a integer value or any value which you are supposed to store. I hope so you got the representation of linked list. So this is the most simplest part that we can talk about the linked list as of now. Now let's check how the node is created. Okay, so before creating a node, we need to remember one keyword from the C++ that is called as a new. So new is a keyword mainly used to create something during runtime. Now how I will be creating the node? As I told you, my representation of node is just like this. Okay, no, I have the int data and I will be having struct node. This indicates a pointer. Since it's holding the address of a next node, I will call it as next. Now say for example I need to create a one node. So how I will create? I need to create a node of which data type of a node data type itself. So I will be simply creating the node of same data type which I have declared over here. So I will be using struct node. What is the name of a new node? Say for example I name it as new node equals to new node So this will be the creation of node. Otherwise you can simply also indicate as like this, size of node. Now what will happen with the help of this? Say for example, new node, which means this new node is created. Now what will its size? Now its total size will be, this is of 4 bytes and this is of 4 bytes, which means the both are of 4 byte each as well. So this will contain a data and this will contain an address. So I hope so you understand how to create the node. This keyword basically helps to create this node during the runtime. That is, we can create the node at any time, even after the compilation of the code. And the second way you can create the node is, it is of during the using the what we call as constructor. Say for example, I declare struct node, just ignore this, struct node, my is of int data, I need to create it as struct node, which is capable of holding the address of a next node. Now I'm going to declare the constructor. So constructor, what it will contain is, it will be contain int, say for example I have the num data, that is I need to create the node for this particular data. So how will I will create? So data equals to as called as num, and what I will do next equals to null. So how does it works? Now say for example I need to create a new node. So what I will do is, I will create a new node like this. So it's called as node star new node equals to new node of 7. Now how it will create a node? So it will simply create a node of 7, and what I said is the next is null, which means here is null. So this is my a node is created. I hope so you got this. It simply 7 goes over here, num is assigned to this, and next, which is contain the address of a next element, and it will be null. So this is how we create the node. I hope so you got this with clear understanding. So as of now we checked what do we mean by linked list, then we checked why linked list, then we checked representation of linked list, and finally we will looking at as a types of linked list, now called as types of linked list. So the first point is, that is of single linked list, and the second type is called as doubly linked list, and third type is of circular linked list. We will be discussing each and every single type of a linked list in detail. So for this video we will be stopping at here. From the next video itself we will be starting with single linked list, then we will come its implementation part, insert at start, insert at end, and then traversal, and many more things. I hope you understand each and every single concept which I taught you. Till then, have a happy coding. Do subscribe the channel so that you can follow this playlist. You will be having a lot of fun. Till then, have a happy coding.